right, let's go up. Let's go over warm-up number 6. Number 1 says, solve the following, answer in reduced form. So, solve the following. A says 5/6 divided by 1/8. So, I really like dividing fractions better than adding and subtracting. Why is it easier than adding and subtracting? Can anyone tell me why dividing is easier? So with adding and subtracting, you have to find a common denominator. Do you have to do that with dividing and multiplying? No. So, anybody know the process for dividing fractions? Autumn? Keep, change, flip. So you keep the first fraction the same. You change the division to multiplication. You use the inverse or the opposite. And so since we're changing that to the opposite, we have to do the opposite of 1/8. We have to flip that. Keep, change, flip. So it becomes 5/8 times 8/1. Now there's two things you can do. You can either multiply straight across and simplify, or you can cross simplify. Did you multiply straight across, or did you cross simplify first? It's a 6. See, there you go. 5/6 times 8/1. Did you multiply straight across, or did you simplify? Just multiply straight across. Okay, so 5 times 8 is 40. 6 times 1 is 6. Can we leave it like that? No, that is what? An improper fraction. So whenever you see this bar right here, that means divide. 40 divided by 6. This one goes inside. Let's see if I can give myself some room to divide up here. 40 divided by 6. How many times does 6 go into 40? 6. 6 times 6 is 36. And 40 minus 36 is 4. So that answer is, your whole number is 6. It went in 6 times. And you have 4/6 left. Is that in reduced form or simplest form, Alexis? What do we reduce it to? 6 2/3 is your final answer. 6 2/3. Can someone tell me what Alexis did to simplify that from 4/6 to 2/3? Anyone know how she did that, Autumn? She divided both the numerator and the denominator by 2. They're both even numbers. 4 divided by 2 is 2. 6 divided by 2 is 3. So that is your final answer. B, 3/4 divided by 1/6. So keep, change to multiplication, and flip to the reciprocal. So 3/4 times 6/1. Did anybody cross simplify? Do you want to do this one by cross simplification? So the way you can do that is you can say, is there a number that goes into those two or a number that goes into both of those two? Well, we can't make those any smaller because dividing both of those by 1 doesn't work. What goes into both 4 and 6, Autumn? 2. So 4 divided by 2 is 2. And 6 divided by 2 is 3. And then you can multiply straight across. 3 times 3 is 9. 2 times 1 is 2. Can we leave it like that? Nope. What do we need to do? Divide. 9 divided by 2. It goes 4 times. 4 times 2 is 8. 9 minus 8 is 1. So your answer is 4 1/2. Can that be simplified any further? No. 1/2 is in simplest form. I know that because my numerator is a 1. It cannot get any smaller. questions on the dividing fractions? No. Write an integer to describe the situation. A town sits 380 feet below sea level. What is the number that represents 380 feet below sea level? Chad? Yes, very good. Negative 380. That's all you have to do. You're just writing that in number form. Do you all have a question, or are you wanting to answer the next one? The next one, okay. $98 is deposited into a checking account. Anna, do you know what that is? Negative 98. Is a deposit a negative? Do you all know what a deposit is? It's when you walk into the bank and you say, here's some money, put it in my bank account, make my bank account bigger. So if something's getting bigger, is that a negative or a positive? That's a positive. A deposit is a positive. Positive 98. I know it feels counterintuitive because you feel like if you're making a deposit, you're giving money away. But what you're doing is you're thinking about what's happening with your checking account. And a deposit is the checking account getting bigger. A debit is taking money out. Have you ever heard your parents say they're going to use their debit card to buy something? That means money's coming out of their account. They already have it. They don't have cash in their pocket, but they are paying money and their bank account's getting smaller. Withdrawal is exactly the same thing as a debit. A withdrawal is when you're taking money out. Okay, so that wasn't a you didn't know how to do that problem. That was a maybe we just didn't understand that vocabulary term. All right, questions? All right, here we go. How many 1/4 servings are in a 12-cup container? So there's a couple of different ways to solve this problem. Anybody tell me one way you solve this problem? EJ? You divide 1/2. We're going to divide that 1/4 by 12 different cups. Yes, we're going to take that 12-cup container and divide it into 1/4 servings, right? So which number has to come first in the dividing? Somebody besides Autumn and Anna. Somebody, Noel, which one comes first in the dividing? 1/4. So that's saying 1/4 divided by 12. And didn't we just say it's not the 1/4 that we're going to split? This is the biggest common mistake that people make, right? You remember yesterday we talked about the commutative property said we can change the order in multiplication and addition, but we can't change the order in subtraction or division. So the one that you're going to split has to come first. So we are going to split 12 and make that a fraction. 12 divided by 1/4. How many 1/4 are in 12? I think that's how you learned it last year. You also learned it where you could break it into pieces. How many 1/4 pieces are in 12? And you could literally do that. You could make 12 cups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And what did you say, Chad? You can technically do multiplication with it. Why could you technically do multiplication with it? So we're going to see in just a minute, kind of. What you're thinking is if I break each one of these into 1/4 pieces, how many 1/4 are in each cup? EJ? 4. That's what you're thinking, Chad. There's 4. And so if each one of those is 4, 4 and 4 and 4 and 4, that's repeated addition, but that's also multiplication. So we could say 12 times 4, and we would get 48 servings. Or we could also divide. But to divide, we keep, change, and flip. Keep, change to multiplication, and use the reciprocal, and flip. Oh, isn't that what we just did there? 12 times 4, and now we're doing 12 times 4. That's the magic of math. 12 times 4 is 48. 1 times 1 is 1. And 48 over 1 is 48. And so last year, I think at the beginning of the year, you all probably should have spent a lot of time looking to see how dividing is the same as multiplying by the reciprocal. Do you think I care which way you solved this problem? No, as long as you got the right answer. I did not care. Now, this is a word problem. It has to have words in the answer. So the question is, how many 1/4 servings are in a 12-cup container? There are 48. Notice how I used a capital letter. There are 48 servings in a 12-cup container. And then you're done. Then when you're done with your warm-up, put it to the side so that you have it tomorrow. And remember, if you're in a morning class tomorrow, which is you guys sitting in here right now, all the math teachers have a meeting tomorrow morning. Mrs. Bent will be here with you. You'll come in the morning. You'll probably see me before I go to my meeting. I'll just be down in the library. I'm here. You'll do your warm-up. She will check it. And then you will have an activity that you can either do on your own or with a partner. If you want to work by yourself, you can work by yourself. If you want to work with a partner, you're going to work with a partner. But you will turn it in tomorrow for a grade. Questions? Okay. All right, so let's look at the first foldable that looks like this: adding and subtracting integers. So I'm still waiting on a couple of journals. They are going to be delivered today or tomorrow. So we'll put these in our journal. We'll start it on Monday. So we're going to work on this today, and then we'll collect them and hold them for you. And then we'll give them back next week when we start our journal. Okay? All right, so with this, you're going to flip it over. You're going to tri-fold. That means fold the right end first, so that you see this notes. Fold the left over. Doesn't have to be perfect. And that way you see the cover right there. And then when we go to put it in our journal, it says glue on dots. If you had glue, you just dot it there, and then you'll glue it just like that in your journal. All right, adding and subtracting integers. We started with some adding integers. Yesterday we practiced using counters and a number line. Today we're going to just talk about the rules. And you'll have a foldable for that. So let's unfold it here. Let's start here with adding. So when you're adding integers, if the signs are the same, you're going to add the integers. The word that goes right here in this blank is add. Add. Do I need to zoom in a little bit? Add the integers and keep the same sign. So if they're both positive, you're going to add them together and keep them positive, right? 2 plus 3 is 5. They're both positive. So your answer is positive. You've known that one forever. If they're both negative, negative 2 plus negative 3. You're going to add them together. 2 plus 3 is 5. And they were both negative, so your answer is going to be negative. All right, so let's look here. Example 1. 4 plus 8. Both numbers are positive, so add and keep the answer positive. 4 plus 8 is 12. They're both positive, so your answer is positive. Example 2, negative 3 plus negative 5. Negative 8. Now, sometimes you might see it like this. Negative 3 plus, and then in parentheses, a negative 5. Does that mean to multiply? No, because it has this plus sign right here. Plus a negative. That just means it's holding them apart. Either way is appropriate. Now, if that did not have a plus sign and it was the -3 right next to the parentheses, then it would be multiply. So both numbers are negative, so add and keep the answer negative. -3 and -5 is what? -8, right? We looked at that yesterday with counters. You would put out 3 negative counters, 5 more negative counters, and then you would just have a pile of 8 negative counters. All right, so let's look at our rule if the signs are opposite. If the signs are opposite, we are going to subtract the integers. This word right here is subtract. The integers and keep the sign of the integer that is farther from 0 or that has the higher absolute value. That's important, not the bigger number, but has the higher absolute value, the bigger absolute value. So if they're opposite, you subtract the lower absolute value from the higher absolute value, and then you're going to take the sign of the integer that has the higher absolute value. So let's look at that. 4 plus -8. Let's think about absolute values. That's a positive, that's a negative. So absolute values, 8 minus 4 is 4. So it's 4. Which one has the higher absolute value? The 8, and it's negative, so our answer is negative. Example 2, -3 plus -5. That's a negative, that's a positive. They're opposite, so what do? Subtract. 5 minus 3 is 2. Which one has the higher absolute value? 5. It's positive, so your answer is positive. That's all there is to it. Those are the rules for adding. Everybody okay with that? Okay. Now, yes. Spencer, are you writing all this down? You're staying with us? Yes. Okay. All right, subtract. There's only one additional rule. Anytime you have a subtracting integers problem, you're going to change it to adding, and then you're going to solve it just like an addition. So just like dividing fractions, you change a fraction division problem to multiplication, and then you solve it just like multiplying. Here, if we have to subtract integers, we are just going to change it, and then we're going to use the addition rules. Okay? So only one rule to follow. Keep, change, flip. A lot of people call this the KFC. Oh, no, that's the KCF. They didn't follow the rule. A lot of people call it keep, flip, change, but keep, change, flip. So, keep the first number the same, change subtraction to addition, and then flip the sign of the second number. This is your rule right here. If you have a highlighter, you can highlight. All right, so let's take a look at example 1. 4 minus 8. 4 minus 8. Keep it. Keep the 4. Change the subtract to add. And change this. If you look here, this is a positive 8. Subtract a positive 8. So if we change the subtract to add, we change the positive 8 to a negative 8. And now we follow the rules. Then we can go back over here. When they're different, we subtract. 8 minus 4 is 4. The 8 has the greater absolute value, so our answer is negative. right? Here's another example. Negative 5 minus negative 3. Well, subtracting a negative is really the same thing as adding a positive. Negative 5 minus becomes plus. The negative 3 becomes a positive 3. So, negative 5 minus negative 3 becomes negative 5 plus 3. The signs are different. Negative 5 and a positive 3. So you subtract. 5 minus 3 is 2. And then is my answer negative or positive? It's negative. The 5 has the greater absolute value, and it's negative. You could think about it on a number line. If you were at negative 5 and you went 3 in the positive, are you going to cross over the 0 to get to the positive section? No, you're still going to be on the negative side. That's why absolute value matters. Are you going to be able to get all the way over the negative to the other side of the number line? All right, here's another one. 6 minus negative 2. It's subtract, so it's keep the 6. Change the subtract to add. Change the negative to a positive. 6 plus 2. What's 6 plus 2? 8. Do we even have to think about the signs? No, they're both positive. It's the same. So they stay the same. Negative 7 minus 8. So negative 7 stays the same. Subtract becomes add. And you have to think, this is a positive 8. So if that's a positive 8, then this becomes a negative 8. Now the signs are the same. What do we do over here when the signs are the same? We're going to add and keep the sign. Negative 7 plus negative 8 is negative 15. Ooh, those were super fun. Weren't those super fun? Yes. Questions? Okay, let's try some practice ones over here. All right. So, is this an addition problem or a subtraction problem? It's addition. Are the signs the same? No, they're different. So, if you're confused, you can come over here. And if the signs are opposite, subtract. So, 12 plus negative 7. Well, what's 12 minus 7? 5. And is it positive or negative? This one has the greater absolute value. It's positive, so your answer is positive 5. All right, this problem, is it addition or subtraction? Subtraction. I have to see you rewrite that problem. So that becomes negative 4 plus what? Negative 10. And negative 4 plus negative 10, the signs are the same, so you add and keep the negative sign. You could also think of this as I'm at negative 4 and I'm going to go 10 more in the negative direction. So if you're thinking on a number line, you're at negative 4 and you want to go 10 more in the negative direction, you're going to go that way and get smaller on the number line. So it's negative 14. All right. Negative 9 plus 8. Spencer? Well, again, you have to look at it like this. It's negative 4 minus 10. So this right here is a subtraction sign. So if you take the subtraction sign away, what is that 10 right there? It's a positive 10. So then when you rewrite it, the negative 4, the subtract becomes add, and that negative 10, or that positive 10 becomes a negative 10. It's hard to see, but you really have to think about this as being separate from that subtraction sign. So if this is subtract, then that means we're changing that to add. So that means that subtract sign is not with that 10. Does that make sense? It's kind of counterintuitive if you can just understand it, like we were doing yesterday. But if you're following the process, that's literally a subtraction sign, so you change it to add. And so if we're not looking at that sign as going with the 10, then that's a positive 10. Does that help? Okay. All right. Negative 9 plus 8. What do we do? Add or subtract? Subtract, because the signs are different. 9 minus 8 is 1. And is it positive or negative? It is negative. Very good. 5 minus negative 3. If it's a subtraction problem, you rewrite it, and it becomes 5. Subtract becomes add. Negative becomes positive. 5 plus 3 is 8. Negative 2 minus negative 9. It's subtraction, so rewrite it as addition. Negative 2 plus negative 9 becomes positive 9. Now you follow the addition rules. The signs are different, so you are going to subtract. 9 minus 2 is 7. And is it positive or negative? Positive, because the 9 has the greater absolute value. It's positive, so your answer is positive. Yes, Zach, rewriting. Can you go? Yes. Thank you. All right. 6. 7 minus 13. So you have to do what? Rewrite it. This one's one of those tricky ones. That becomes 7 plus negative 13. They're opposite, so you are going to what? Subtract. 13 minus 7 is 6. Is it positive or negative? Negative. Last row. 8 plus negative 6. So it's already addition. The signs are different, so we are going to what? Subtract. 8 minus 6 is 2. Positive or negative? Positive. The 8 has the greater absolute value. It's positive. So your answer is positive. Last one. What do we do? Anna? Change it to an addition problem. So that's 1 plus. If I change that to addition, I change that to a positive. 1 plus 4. And 1 plus 4 is 5. Questions on that? All right, let's look at the notes on the back. So here's some reminders. Make sure you fill this in. We are going to take a mid-unit assessment next week, or a mid-chapter. And there's one of the questions that's going to ask you the definition of an integer. It will be open notebook. So if you have the definition of integers written in your notebook, guess what? You can use that on the assessment next week. You're not going to believe how many people are going to go check their notebook and not have the definition. It's going to be sad. They're going to come up to me and go, oh, can I get it now? And I'm going to be like, I'm so sorry. No. So make sure that you're writing things down, because a lot of times I'll let you use your notebook. All right. So integers, they're the set of whole numbers and their opposites. A set of whole numbers and their opposites. So it's what you see on the number line. An integer is not a fraction. It's not a decimal. It's not a mixed number. 1 5/10 is not an integer. 1 is, and then all the opposites on the negative side are. To the left of 0, blank numbers go on to infinity. So are they positive or negative to the left of 0? Negative. The negative numbers go to infinity that way. There's always one smaller number to the left of another number. To the right of 0, blank numbers go to infinity. What word goes in there? Positive. So opposite, an integer that is the same distance from 0, but the opposite side of 0. Same distance, but opposite side. That's what we want for a definition of opposite. Let me change my pen again. If you're having trouble reading anything, you can raise your hand and ask me. I don't have the neatest handwriting. Opposite is an integer that is the same distance from 0, but it is on the opposite side of 0. So what is this a picture of on this number line? What are they trying to show us? This is a picture or a diagram of opposites. And what are the opposites they're showing us? 4 and -4. They are opposites. All right, we already talked about absolute value. What is absolute value? Distance from 0. I want you to also put on there that it is always positive. Absolute value is always positive. There it is. The distance of an integer from 0 on the number line, it is always positive. And I'm going to highlight that statement. That is super, super, super important. Always positive. Distance is always positive. So what is the absolute value of 8? 8. What is the absolute value of -8? 8. That's what you need to know about absolute value. And when you're done with that, you can put that to the side, and we're going to look at that flow chart. Some of you, the flow chart will come in handy, and some of you will say, I don't need that too. That's okay. And we're actually going to put this flow chart up on the wall in the classroom too. That way you don't have to drag your notebook out every time you want to look at it. Anyone still copying this? Okay, let's look at the flow chart. This is what you're going to need your highlighters for. All right, so we're working with integers, right? You come to a problem. You don't remember what to do. Start here up at the top. You all know how to use a flow chart? Okay, so start up here at the top. Are you adding or subtracting? Well, if you're adding, you're going to follow this side. You're going to come this way. And then you're going to get here. Do the integers have the same signs or different signs? If they are the same, you're going to keep. You keep the sign the same, and then you add the digits. All right, so if you're adding, and then you read the question, do they have the same sign or different signs? If they have different signs, you're going to keep the sign of the integer with the greatest absolute value, and you subtract. So if they're different, I'm going to use a different color. Keep the sign of the number. I used a number sign with the greatest, I forgot my T, greatest absolute value. And then you are going to subtract. Everybody good? All right, we'll wait a couple more seconds. I heard a couple no's. So this is the flow chart. This side is if you start with a problem that's adding. But what if we start with a problem that's subtracting? So we're going to go here. If we're subtracting, we're going to go to this side. If it's that side, you're going to copy the first integer. Copy the first integer. This is called adding the additive inverse. I'm just going to write this over here. Adding the additive inverse, or adding the opposite. But the term's called adding the additive inverse. So, subtracting. We're going to copy. We're going to change this sign to addition. Then you're going to change the second integer to the opposite. And then, after you change it to the opposite sign, then you follow this flow chart. Watch. Go here, here. And then you have to follow the rules for addition. So, your flow chart for subtraction, keep, change, flip. And then you've got to go up and you've got to follow the rules for adding. You're never done until you get down to one of these two places. This is the end. You cannot end over here. You have to follow this over and then follow the rules for adding. If you get done with this, you can set it to the side and you can try that half sheet of paper that's adding and subtracting integers. We'll do some of them together in a minute. Some of you might want to use this flow chart. Some of you might think that the foldable's easier. Whichever one you think is easier for you, use if you need to look back. So let's talk about one thing as we were going through these notes. Do you see how when I was following the flow chart and I went this way, I kept the highlighter color the same because this was the pattern for same? And then over here on this side, I kept the orange because that was that side. And then over here on subtracting, I kept the highlighter the same. So try to make sure that when we're doing notes, that if I'm keeping colors consistent, like I used yellow, 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 that means those went together. So you didn't have to use yellow. If you had green, you should have gone green, 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 right? Does that make sense? If you didn't do it right this time, that's okay. But I know that to a lot of us, taking notes is new, and that's okay. All right, anybody still copying this flow chart? Okay. Do we want to do some of these together, or are you wanting to give it a try on your own? If you say try a few together, raise your hand. Okay. I'm going to do maybe the first 4. If you don't want to stay with us, you don't have to. You can keep going on your own. If you want to do the first 4 with us, you can stay with us. All right, number 1, 1 plus 15. Well, you've been able to do that one for years and years. What's that answer? 16. 2. -6 minus -17. Remember, you have to show your work changing it to addition. -6, change the subtract to add, and change the negative to a positive. Change that subtraction to an addition problem over here. Copy, change, change, then go up and follow the rules for adding. They are different. So we're going to keep the sign of the one with the greatest absolute value, but we're going to subtract. 17 minus 6 is 11. The 17's greater, it's positive, so our answer is positive. If you did number 2 and you did not rewrite it to an addition problem, I will put a great big old X on it. Even if you got positive 11, just because I'm that mean. Okay. 19 minus -2, it's subtraction, so you have to change it to add. 19, subtract becomes add. The negative becomes positive. 19 plus 2 is 21. -13 plus 20, well, it's already an addition problem. Signs are different. Signs are different. So keep the sign with greatest absolute value, but you must subtract. 20 minus 13 is 7. 20 is the greatest absolute value. It's positive, so your answer is positive. Questions? No? Okay. All right, keep working. If you have a question, come see me or Mrs. Bent, or if this is in another class, Mr. Millwood, and we will be happy to help you.